Okay, the second case of the integration by trigonometric transformation is the integral of powers of sine and cosine. So consider, for example, the integral of powers of sine or cosine or product of such powers of this form. So this is integral of product of powers of sine and cosine, where m is the exponent of sine and is the exponent of cosine. So to integrate this, now you have to look for the exponent of sine and cosine, whether odd or even. So if n is odd, meaning the exponent of the cosine function is odd, then you have to factor this trigonometric function into two factors. One is cosine of degree 1 and the other one is cosine of degree n minus 1. And then after that, we transform the cosine of degree n minus 1 to sine function using this identity that cosine squared x is 1 minus sine squared x. But in case that m is odd or the exponent of the sine function is odd, then you have to factor this also into 2. One is degree 1, so you have sine x, and the other one is degree n minus 1. Yes. And then after that, we will transform the sine function of degree m minus 1 to cosine function using this identity. No? Sine squared x is 1 minus cosine squared x. But in the case that you have only, let's say, the integrand is a cosine function of degree, let's say degree n. So if n is even, then you have to use the last formula, which is cosine squared x is 1/2 of 1 plus cosine 2x. But in case that you have only sine function of degree m, which is even, then you have to use this formula. Sine squared x is 1/2 of 1 minus cosine 2x. Okay, suppose we are asked to evaluate the integral of sine to the 7 2x cosine cube 2x dx. Okay, because the integrand is a product of powers of sine and cosine, so we make use of the integration by trigonometric substitution. So to use that, now we have to check which function, the sine function or the cosine function, has the smallest exponent. So because the exponent of cosine is smaller than the exponent of sine, so we have to factor this into 2. One is cosine 2x, and the second is obtained by decreasing the exponent of cosine by 1. And then because this is odd, so we will make use of these trigonometric identities that cosine squared x equals 1 minus sine squared x. Okay, so let us first rewrite or factor, okay, cosine cube as cosine squared 2x times cosine 2x dx. Okay, so from cosine cube 2x, we rewrite this as cosine squared 2x and cosine 2x dx. The purpose of isolating cosine 2x dx is this will serve as your du. If you let u as sine, then the differential of sine is cosine. So this will serve as your dv. And then, but before you do that, now you have to transform this cosine squared 2x into sine function now by using this identity. And from this trigonometric identity, since the argument of the given is 2x, so we have to change x by 2x. So we have cosine squared 2x is 1 minus sine squared 2x. So we can now rewrite this as the integral of sine to the 7 2x times cosine squared 2x using the trigonometric identity is 1 minus sine squared 2x times cosine 2x dx. And then by distributive property, sine to the 7 times 1 times cosine 2x this can now be written as sine to the 7 2x times cosine 2x dx. Okay, minus sine to the 7 2x times sine squared 2x times cosine 2x dx. So this can now be written as the integral of sine to the 7 plus 2. So you have 9 of 2x times cosine 2x dx. Okay, so we can now let u be the trigonometric function sine 2x. And then r du now is the differential of sine, which is cosine 2x times the differential of 2x is 2 dx. So same here, we let u as sine 2x and then your du is 2 cosine 2x dx. But because the integrand has no coefficient of 2, so we have to solve for cosine 2x dx by dividing both sides of this equation by 2 to get du over 2, or 1/2 du is equal to cosine 2x dx. And then by substitution, yung sine to the 7 2x, now this can now be written as u to the 7. And then cosine 2x dx, this is equal to 1/2 du. Okay, minus. So same here, sine 2x is u, so you have u to the 9 power. Then cosine 2x dx is 1/2 du. Then factoring out the constant coefficient 1/2, so you have 1/2 times the integral of u to the 7 du minus 1/2 times the integral of u to the 9 du. And then by applying the power formula, diba, this is integrable by adding the exponent of u by 1. So this can be written as u raised to 7 plus 1, which is 8 all over 7 plus 1, or 8. Okay, minus 1/2 times the integral of u to the 9 du, which is u to the 10 using the power formula over 10. Now plus the constancy. Or this can be written as 1 over 1/2 times 1/8 is 1 over 16 times u to the 8, where u is sine. So this should be sine to the 8 power 2x minus 1 over 20. Then you have sine to the 10 power 2x plus the constancy. So this is the final answer. Okay, so suppose we are given another example, which is integral of cosine to the 4th x dx. So as you can see, because the integrand is powers of cosine, so we will make use of integration by trigonometric transformation. And as you can see, because the exponent is even, so we will make use of this identity that cosine squared x is 1 plus cosine 2x all over 2. But before we apply this, because this is degree 2, so we have to rewrite cosine to the 4th as cosine squared x quantity raised to the 2nd power dx. Okay, so cosine squared x raised to the 2nd power. But what is cosine squared x? From this identity, cosine squared x is 1 plus cosine 2x all over 2 dx. And then we factor out 1/2, so we have the integral of 1 plus cosine 2x quantity dx. Then by distributive property, you have 1/2 integral of 1 times dx is dx plus 1/2 times the integral of cosine 2x dx. Okay, but we know that the integral of dx is x. And to integrate this, we let u be as 2x. And then taking the differential of both sides, so du is 2 dx. But because 2 is missing, so to solve for dx, you divide both sides of this equation by 2. So we get 1 half du or du over 2 is equal to dx. So you can rewrite this as 1 half times the integral of cosine 2x, where 2x is u, and dx is 1 half du. Or this can be written as 1 over 2 times x plus 1 half is 1/4 times the integral of cosine u du. So we have 1 half x plus 1/4. But recall that the integral of cosine u is sine u, where u is 2x. Okay, plus the constant c. So this is the final answer.